Okay, let's talk a little bit more about Audacity. Just some ins and outs that'll help you with the Audacity and Pratt assignments in modules 1 and 2. So the first thing that I've got in the slides here is just a difference between fundamental frequency and fundamental period. So a lot of people are getting a little confused with fundamental frequency, fundamental period, frequency, and period. There's these four different things. Why are there four? And so fundamental frequency is similar to frequency. Fundamental period is similar to period. So it's kind of like frequency is a general term and fundamental frequency is a specific frequency. Period is a general term. Fundamental period is a specific period. So fundamental frequency is the lowest frequency in a complex tone. It's also the carrier frequency in a complex tone. So what I mean by the lowest in a complex tone is the lowest pitch, the lowest number. So here I've got 300, 600, and 900 hertz tones. 300 hertz is the lowest frequency in that grouping. So that's the fundamental frequency. The fundamental frequency is also the carrier frequency of a complex tone. And what I mean by that is as a sound pressure wave, like moving through the air, 300 hertz is the main pressure wave that is moving through the air. 600 and 900, of course, are as well. They're embedded within that pressure wave. But the 300 hertz tone is the strongest one that's moving through the air. And then lastly, 300 hertz tends to be the pitch that we actually perceive in a complex tone. So if we were to listen to this, and actually we can do that, because if I go over to Audacity, here's Audacity. Here's my 600 hertz, my 300 hertz, and my 900 hertz tones. I'm going to mute my microphone, because if I don't, you'll hear two things, and that'll be annoying. But let's first listen to, what I'm going to have you listen to first is 300 hertz, this one here, then 600, then 900. I'm going to go back to, let's do it opposite order. We're going to do 900, then 600, then 300. Then we'll do all of them together, and you can see which one the group sounds more like of those three tones. Like I said, I'm going to mute myself so that you only hear one of these and not like an echo. So hopefully you could hear that it was very high, medium, and then a pretty low sine wave. When I played all of them together, the pitch was the same as the 300 hertz sine wave. The timbre wasn't. Like, it sounded like a different instrument. Timbre's like what instrument is playing. So you can play like the same note on a guitar, like this guitar over here, right there, and a piano, which I have one in here, but you can't see it. And they're the same note. They can play in harmony, but they sound different. Like, you can tell if you just listen to one that it's a guitar or a piano, or even if you don't know anything about guitar and piano, you could hear that they were different in some qualitative way. Like, you wouldn't think that they were from the same instrument, and that's the timbre. And so what you heard here was a difference in timbre. One sounded like boo, and the other sounded like wah, but the same pitch. So all three tones are playing, but the fundamental frequency is the one that you perceived. So that is another reason why we call that the fundamental frequency. There's 3 reasons why we call it fundamental frequency. It's the lowest frequency, it's the carry frequency, whoops, and it's the pitch that we actually perceive. Now, fundamental period, that's pretty simple. That's the period of the fundamental frequency. Ba-dum-bum, that's it. So we can talk about any frequency. It can have a period. How often, how long does it take for one cycle of the wave? And the fundamental frequency is a frequency. You can find out the period of the fundamental frequency, and we just call that the fundamental period. So if you're confused about all 4 of these terms, that's okay. But hopefully now this should kind of clear it up, like how they're different. And essentially, frequency and fundamental frequency aren't really different. They're like, it is a frequency. It's just a special frequency that exists in a complex tone. And then fundamental period is just the period of that frequency. So it's really not different than period in general. It's just the period that goes along with the fundamental frequency. Okay, so that's it for the slides that I want to talk about. Let's go back to Audacity. I can keep myself on this time. Let's look at how to calculate. So I've got now the newest version, the newest release of Audacity, which you've all got as well. And let's look at how to calculate frequency. Down here, these don't get a high enough resolution to calculate an exact period or frequency. So let's not focus on those. What we're going to do is we're going to go here to zoom in. Let's zoom in pretty far. Not too far. This was too far. You can see the structure of the universe. You don't want to be there. There we go. So this is a good distance to be zoomed into. Like just one back from too far. So what we're going to do is we're going to start here, and we're going to look for where where one full cycle coincides with one of these tick marks, or like exactly in the middle of 2 tick marks. This one isn't. So it's kind of hard to see. Let's go to another one. Another one. Pretty close. Pretty close. So I'd say that's like, if it's not dead on, it's close enough. So you can see up here, the time that we've got is 0.005 seconds. We've got 1, 2, 3 repetitions in 0.005 seconds. So all we're going to do is take 0.005 seconds, 0.005, divide that by 3. And we end up with this answer that you can't see. There we go. 0.005 divided by 3. And the answer I end up with is 1.666 repeating to the negative 3. Is that what it says? To the negative 3? Yeah. So essentially what we're going to do is we're just going to count backwards decimal places. So instead of 1.6, it's going to be 0.16, 0.016, 0.00167. So then the answer for this one, the period, is 0.00167. Or 0.0017. Not really a reason to have more than 4 decimal places on that one. And if we do that, if we put that into our formula to figure out what the frequency is, it should be 600. We'll do 1 divided by 0.0017 equals 588. Okay. Let's backtrack on what I said. Let us go to 5 decimal places, because this is too far off. 1 divided by 0.00167. 598. Yep. You want to go to 5 decimal places. Go to 5 decimal places. And then here you are. at 598.8. You could round that to 599. And that's so close to 600, it might as well be 600. Great. Okay, let's take a look at the next frequency. So here's 1 full revolution. No. 2. No. 3. Yeah. Right on 0.01. We got 3 again in there, so we're going to do 0.01 divided by 3. Gives us 3.3333333 to the negative 3. So that means it's going to be, if we're going to do frequency from this 1 divided by, we're going to go to 5 decimal places, 0.00333 equals 300.3. And that's close enough to 300. Okay, and then the last one. Here's 1 full revolution. No. 2. Whoops, I lost hold of it. 2 is... Well, 2 is pretty close to halfway between these 2 tick marks here. I'm gonna say... Let's just see where 3 is. 3? No. Okay, let's go with this. So if this is 0.002, this is 0.003, that means this tick mark that doesn't have a label is 0.0025, which means halfway in between is 0.00225, right? And there's 2 in there, so we're going to have to divide 0.00225 by 2. We end up with 1.125 to the negative 3, which means that the actual answer is 0.001125. We'll do our formula calculation here, 1 divided by 0.001125. 889. It should be 900, but that's pretty close. So this would round to like 890. It's only 10 hertz off. The higher you get in frequency, the less precise this measurement is going to be. Okay, so that's one method. Let's look at another method of figuring out what this frequency is. Let's just work with one frequency right now. So let's zoom out. There we go. Let's work with the top one, which is 600. We're going to grab some of it. We're going to go to Analyze, Plot Spectrum. Not enough data selected, so I need to select more. Let's grab that. Analyze, Plot Spectrum. There we go. Looks like this. There's your peak, and you get your cursor. Remember, you get 2 things. You get a cursor and a peak. Your cursor is measuring exactly where you are. Do not report that measurement, because I can be way over here at 1,115, and it's still clicking me into the peak. So don't give cursor, give peak. That's the one you want to look at. So peak is telling me 600 hertz. Good. Let's close that. Let's grab all 3 of these. You can do it with multiple harmonics. We're going to go to Analyze. We're going to go to Plot Spectrum. And there we go. How many harmonics are present? 3. 1, 2, 3. The fundamental frequency is a harmonic. It's the first harmonic and it's the fundamental frequency, so it counts for both. So really you just count up the peaks, and that's what you report. And then you can hover over and look at peak, not cursor. This is 301, close enough, 600, and 900. What if you have to give the fundamental period of these, and you've done it like this. Well, all you have to do is, so you've got 301 or 300, 600 and 900. You can work backwards. You don't have to calculate it the way that we did before of like highlighting and counting them. You can also say go to 900, 1 divided by 900, and you get 1.11111 to the negative 3. So you could report that as 0.00111. And that would be your answer. Okay, one last thing. This is all for Module 1. And so I'm going to show you something for Module 2 that should help you out, which is where the heck do you make your filter curve? It's changed places in the most recent update. Cool. Why? I don't know. So now if you go to Effect, you go to EQ and Filters, you have Filter Curve EQ. Yeah. Select the audio. EQ and Filters, Filter Curve EQ, and here we go. So that's where it is now. That's where you'll find it. It's like almost in the same place. It's just not quite in the same place. So I don't know. Thanks for changing that on us. What do you think this looks like if we apply this to these 3 frequencies? Oh, okay. Yeah. Great. That's not as good as applying it to white noise. It looks kind of dumb. All right. There you go. There's some new things that will help you with Modules 1 and 2 homework. All right. See you in the next video.